Hey guys, welcome to our first day of e-learning. I know this is weird and it's different, but I promise you we're going to get through this together. I have a whole plan set already in terms of how we're going to address different things that might come up. So the big thing is that I need you guys watching these notes. I suggest that you watch them on your phones and then you take the notes along with me on your iPad just so that your brain is doing some of the thinking. But we're going to do notes. We're still going to do homework assignments. Actually, this homework assignment for tonight will be on Schoology. You'll open it up and you'll send it back to me on Schoology by the time of class time tomorrow. I'm still going to give you answers to the homework. I'm still going to have ways to make sure that if you have questions, we're going to fill out the Google form and I will make a video of the problems that people have questions with. So we're still going to do a lot of things the same, but bear with me. Be flexible, and please do your homework each day, and please watch your lesson each day so that way you don't fall behind, because we will be working towards an assessment of some sort when we get back together. So today we're starting chapter 10. Chapter 10 is a lot about area of different things. So the first chapter, or the first section right off the bat, is area of shapes that we talked about in chapter 6. So we're looking at parallelograms, trapezoids, kites, rhombuses, and they also threw triangles in here again. So part of what you need to understand when you look at these formulas is what each of the letters stand for. So if you look at the parallelogram formula, the B in the parallelogram formula stands for base, and the H stands for the height. If you went back to when we first learned about area in chapter 1, we made a big deal about base and height. The base and the height always have to make a right angle. So every time you're looking for the base and the height, you're looking for the two pieces that make the right angle together. If they don't make a right angle, it's not the two numbers you want to use. So same thing for triangle. The triangle just also has a 1/2 formula in front of it. The triangle formula is 1/2 B times H. B means base, which is this whole bottom side, and H means height, which is this side right there. A lot of times the height is going to be drawn as a dotted line, so just pay attention to that. Sometimes for a triangle and also for a parallelogram, it might be located outside of the triangle or parallelogram, and that's okay. You're just looking for where that right angle is. That's what you want to pay attention to. Wherever the right angle is, those are the two you want to use together. All right, then we have a trapezoid. Trapezoid formula is 1/2 B1 plus B2 times H. Those parentheses are going to be important when we see our first example, but realize both of these just refer to the bases, which, remember, for a trapezoid, the bases are the parallel sides. So if you find the two parallel sides, those are the two that we want to use. And then the kite and the rhombus, if you look over on the right, have the same formula, but you really need to understand what that D means to the picture. So let me zoom back out here. So the D in the formula means we're looking for the diagonals. And when we look for the diagonals, you need to use the whole diagonal. So to get the whole diagonal, you're going to have to add the parts together. Part plus part equals whole. So when we look in the picture, D1 would be one of these diagonals going that way. You could call that D1, and D2 is this other diagonal. A lot of times they're going to give you the pieces. You're going to need to add them to get the whole diagonal. And then same thing here. We call one of them D1. We would need to know what that whole piece is. And then this other one we would call D2. It is important that you remember for a rhombus that the diagonals are bisected. So this piece is equal to this piece, and these pieces are equal to these pieces. So it's important that you remember that for the examples we'll get to. So here's our first example. We want to find the area of the figure. So the first thing you do need to determine is what kind of figure it is. This first one happens to be a parallelogram. So the parallelogram formula says that the area is base times height. You just need to pick the correct numbers. There's an extra number here that you don't need to use. So again, what you're looking for is the two that make a right angle. So I'm looking here and here. It's those two numbers together that make the right angle that I want to use together. So that's going to be 12 times 20, which means my area is 240. And then it should be centimeters squared is what we want to make sure we put on as the units. Number 2 is also a parallelogram. So we're using the same formula, base times height. But again, you're looking to find the two that make the right angle. So this one, what you have to be careful about is the right angle is actually outside the triangle. So this one is definitely the height. The base then would be where that right angle would, if we follow this dotted line over, where it connects to the parallelogram. And please remember what you know about the two sides of the parallelogram, that this 5.8 could move over to the other side. So it's those two numbers that we want to use in our formula. We have to do 3.5 times 5.8, and that gives me that the area is 20.3 meters squared, again because we're doing area, the units are squared. Alright, the next shape is a triangle. So since it's a triangle, my formula for a triangle is 1/2 b times h, which is 1/2 base times height. But what we need to look for to locate those is still that right angle. So the 4 for sure is the height. The base would be that whole side that it meets up with. So if they give it to you in pieces, you're going to have to add them together. And that's going to be 7 meters as the base. So that's going to be 1/2 of 4 times 7. And then you can decide when to use the 1/2. You need to use it just one time. So you could use it on the 4 right now, or you could multiply them together first and then take half of it. Either way, you should get 14 meters squared. Number 4 is also a triangle. So we're using the same formula, 1/2, don't forget the 1/2, 1/2 base times height. But this one, this time, the right angle is outside the triangle. So the 3 is definitely the height. But the base would have to be, if we followed the dotted line, what that side that's actually solid on the triangle is. We're going to use that too. This outside number is not going to get used. The base can't be dotted. The height can be dotted, but the base can't be dotted. So you need to find the solid part to figure out what the base is. So this is just going to be 1/2 of 2 times 3, which is 1/2 of 6. And you get 3 feet squared. Okay, let's try a couple more. And number 5, first thing you gotta do is recognize what kind of shape this is. Maybe if I drew these symbols in, it might help. Because it's one pair of sides that's parallel, that means that it's a trapezoid. So I'm using the formula 1/2 base 1 plus base 2 times height. And then if I plug into the formula, the bases are those two parallel parts. So this is a base and this is a base. And then the height is the one that has the right angle, that dotted line in the middle is your height. So it's going to be 1/2 of 18 plus 6 times the height is 9. And then you do need to follow your order of operations. The first part is the parentheses. And then you can either take half of the 24 and multiply by 9, or you can multiply them together and then take half. If I multiply those together, I get 216, and then if I take half, I get 108 feet squared. Okay, let's look at number 6. For number 6, this is also a trapezoid. So I'm using the formula area equals 1/2 b1 plus b2 times h. So when I look at this one in particular, there's something that's awry. If I try to find the height right now, that is actually missing. I don't know what the height is in the picture. It is missing, so I would call it x, and we actually have to go back to something from last chapter to figure out what that height is. So the height actually is part of this whole right triangle here. So we could do x squared plus 3 squared equals 5 squared to help us find the height. This is going to happen occasionally in a trapezoid one. I did warn you on the homework. It tells you that you're going to have to use Pythagorean theorem. So just watch for that in the homework and find what it is you need. Sometimes it'll be the height that's missing. Sometimes it'll be part of the base that's missing. But you're going to have to use Pythagorean theorem to figure out that missing part. So if I subtract, I get 16. And then if I take the square root, that missing part actually ends up being 4. So this guy now is 4. So I've got my height. And then the bases are this side and this side. This whole side we know is 6. it's this whole side that we don't know right now. So just be careful. Don't just jump and use the 3. Make sure you're using the whole base. You have to make a little inference about what's going on in this trapezoid. Since this part is 6 and this happens to be a rectangle inside of the trapezoid, this is also 6. So that whole base is going to be 9. So we're going to use the 6 and the 9 as the bases, and we're going to use the height is 4. So it's going to be 1/2 of 6 plus 9 times the height we figured out is 4. And then it's going to be 1/2 of 15 times 4, which is 1/2 of 60, which tells us that the area is 30 feet squared. So just make sure you're using the right numbers, that you're not just jumping and using the numbers that are there. We didn't use the 5 as the height because it didn't make the right angle. Since we didn't know the one that made the right angle, we had to use that triangle to help us figure it out. Alright, 7. Think about what kind of shape that is. Hopefully you remember back from chapter 6 that this is a kite. So it's going to be 1/2 d1 times d2. What I need you to be careful about with these is d1 means I'm finding the whole diagonal going one way. It doesn't matter which one you call d1, but I'm going to find that whole diagonal. d1 there is going to be 16 because I have to add the parts to get what the whole diagonal is. Then the other diagonal is going this way, so I'm going to call that d2. d2 is going to be 2 plus 8. Make sure you're adding them together. And d2 would be 10. So then the area is 1/2 of 16 times 10, which is 1/2 of 160. And we get that the area is 80 inches squared. So number 8 is a similar kind of idea. This is also a kite. We're doing 1/2 d1 times d2 to find the area. And the diagonals, again, we have to measure what the whole diagonal is. So going this way, that whole diagonal is 6. And going this way, that whole diagonal is also 6. 2 plus 4 is 6. 3 plus 3 is 6. Just make sure you're adding to get the whole. So then it's 1/2 of 6 times 6, which is 1/2 of 36. And we get 18 meters squared. All right, we've got a few more on the next page.